Good morning, good evening, good afternoon to people around the world. This is Martin Hubel, your host of the DB2 Night Show. And today we once again have our special guest with us, John Hornibrook of the IBM Toronto Lab, who's the optimizer guru. So we're always happy to have John here. How are you today, John?
I'm doing great, Martin. How are you?
Fantastic. It's Friday, TGIF. That's what I say when I put my snow boots on before I go to shovel. Toes go in first.
You're going to need them later today, I understand.
Yeah, we're getting about an inch or two. That's not a lot, not like last week when we had a foot of really heavy wet snow. It was awful. So
yep.
But we can tolerate one or two more little snowfalls. It is still winter after all. But we set our clocks ahead this weekend. That's the other big news in North America. We do that. I'm not sure. They do it at a different time in Europe, around the end of March, I believe, or around the start of spring. We're a little earlier over here. And who knows, one of these years they say we're going to go and stay on summertime all year round, provided New York and Quebec agree to do the same things. So we'll see how that works out. Anyway, let me do the housekeeping and so we can get on with hearing what you have to tell us today, because we're more interested in that than the housekeeping. As always, our Twitter, follow us, the hashtag DB2Night on Twitter. That will give you updates on when replays are available and what new shows are coming up with registration information. We also have the replays available on YouTube, which is quite handy if you don't want to download anything. And of course, with YouTube, you can skip ahead if you've seen part of it and that sort of thing. Disclaimers and our trademark stuff. We respect people's trademarks. We're recording the show, and you'll be able to get replays. And John, if you're agreeable, we'll also have the slide deck for you as well. Moving on. We've got today's show. The next DB2 LUW session will be Phil Nelson, my good friend, talking about DB2 UDFs beyond the basics. That show likely will have some applicability as well for the DB2 on Z environment as well. Phil works on both in his day job, so that'd be just great. May 12th, we're having Dale McInnes talk about DB2 Always On architecture. They're talking about that's coming out around now or soon, and I've got to get around to booking the last show of the year for LUW, which would be on June 2nd. This month, on the Z side, we have use profiles to monitor or using profiles to monitor and control DB2 application context with Mariella Wyrock, another great speaker. We're always happy to have her as a distinguished engineer from Silicon Valley Lab. Then we have two long friends of the DB2 Night Show, Cheryl Larson and Dave Belkey. I've got to poke Dave and get his topic, but I know he'll have something interesting to say. And we finish off the year with DB2 User Experience Transformation Strategy, again from the IBM SVL. Somia will be on to talk about that. So the year is filling up, and it's looking really good. As always, our primary or founding sponsor of the DB2 Night Show is DBI Software, so we always like to put a plug in for what they do, which is DB2 LUW performance tools, and they have a demo you can watch there. We also announced last show that DBI is now supporting SQL Server as well. So if you're also running SQL Server, you can look at the DBI tool set and expand your use over to SQL Server. Our winner last month was Elmer Delgado of Manulife up here in Canada. Congratulations, Elmer. You should have already received your gift certificate. And just again, thanking our sponsors, DBI and yours truly. With that, we're into the polling section of our show. Let me just get those. I'll select a poll and launch it here. And some of these questions are typical. You've seen them before, and you know what to do. What current versions of DB2L you're running? I meant 11.2 or higher, but bit lower than 11.6, and then also seeing if you've got some other stuff that's well aged and well used down in the older versions of DB2. Sometimes people want to move on, but sometimes the vendors have not yet announced support for the newer versions of DB2 based on what products you're currently running from applications and that sort of thing. With that in mind, let's shut that off. Share the result there. We've got most people have a new version around. That's absolutely great. And we have people that have older stuff around as well. This poll was set up so that people could indicate more than one if they had to. Next question. Which explain tools do you use? And John and I were discussing this. I told him I often still use Db2 Explain because it's short and sweet, but the lab likes you to use Db2 XFMT because there's far more information. I'm not against Db2 XFMT. It's just that if I can do a quick and dirty and see what's there, I'll often use Db2 Explain. And keeping that in mind, looking at what we have from the audience, there's a number of people out there, John, that seem to agree with me.
You're right, Martin. Well, I'll argue my case in a few minutes.
Absolutely. I think, as I mentioned to you before, I have nothing against EXFMT, but I often just, if I can get the job done with the with the one, I use that first simply because it's more concise. It's like a Reader's Digest, condensed, explain. But
we'll have to add that option.
You know, I just realized that I'm showing my age by saying Reader's Digest condensed. I mean, how many people in the world never knew that Reader's Digest had books that they'd condensed? All right.
I see some on my bookshelf. So.
Yeah, we all have them lying around and they're too good to throw out, right? But then they used to show up monthly. All right, this was on automatic run stats enabled. Let's close. The people were doing that while I was chit-chatting. Do you have automatic run stats? 50% said no, and 38% said on some databases. Interesting. And I think we're getting down. Oops, we have optimization profiles. I'm hoping most people say no on this. I'm not a big fan of them. Reason being is that you're trying to get the optimizer to do something that otherwise you wouldn't be doing. It doesn't want to do. And I find that often you can go in and fix things such that your access path turns out to be what you want, by understanding what's going on by looking at the statistics.
That's a great approach, Martin. So,
and again, people seem to be agreeing with me. It's just that I'm such an agreeable guy today. The days are getting longer. It's just wonderful. Okay. And have you tried the Machine Learning Optimizer Technical Preview? And it looks like you've got some work to do on this, sir. In terms of what people are saying about it. Nobody's tried it. A lot of people say no, and 33% say, "What is it?" So.
Wow. Okay, we'll have to. You'll have to get Callisto on one of your shows to talk more about it.
You know, that's a good thing to do, and I've got a slot open in June. I'll give Callisto a poke and see if it'll help us out. That'd be just great to do. And I did share that, didn't I? Or yep. I was talking about sharing it. One of the two. All right, so we'll close those off for now. That's the end of that. We've got our final polling question, which is just, did you learn anything? And we'll worry about that at the end of the show, of course. So with that, John, I'll turn things over to you. make you the presenter here. You should have that little message on your screen, and we should see your screen momentarily.
How about that?
You find that button?
Yeah, it says, although it says screen sharing is now paused.
Oh, okay. Well, hit it again or something. Here.
How about, I don't know.
It says on my end, it says waiting to view your screen. So I think the thing's on yours. You want me to take it back and try it again? Let's do that. I'll make myself the presenter again, show my screen, and we'll try it this time again. We'll make you the presenter. You should have that message popping up again. And
How about now?
no, not there yet.
What?
Oh, it's the joy of technology. We even tested it to make sure it worked before we started the show. Can you go to full screen mode and back in?
Yeah, I'm going to start just in non-presentation mode.
Sure.
Give it another shot because that worked the last time. Let's give it a shot.
Yeah, that's it. Ticket. All right, I'll take it back and do it one more time, where you take over, and when you're out of presentation mode. I think we've learned something new today. Now give that a shot. There you go. It did work. I can see your screen now.
And now it's in
now you're in full screen mode.
All right, we're good to go. Okay.
All right, thanks. I'm going to mute myself and watch the question queue.
Okay, great. And everything's advancing fine. So I'm first page here. Great. Just a quick overview on the objectives for this session. Whoa. So let's try that. Okay. Yeah, so this is primarily about the explain facility. So some of the things I want to cover here, exactly what is the explain facility. Part of it, we're going to talk about where access plans can exist and how to explain them. So, the folks are probably, fairly familiar with just, take an SQL statement and explain it, but sometimes actually getting that SQL statement isn't that straightforward. So I'm going to talk about some of that, which is, ties into getting the explained information as a query actually executes. And then I'm going to talk about how to make sure that all the important information is included in the explain. So there's some options on explain where you can include more stuff, especially about statistics, maybe some extra runtime information, and then kind of tied in with monitoring and using the explain facility. There are mechanisms that you can understand how access plans might be changing over time, which is kind of important to understand, maybe changes in performance. And then throughout, maybe a little bit of information about how to interpret and understand the explain information. So first of all, what is the explain facility? So it's an internal phase of the query optimizer that after the optimizer's built the access plan, it'll capture that information and it writes it to a set of tables. And so the access plan is what tells the Db2 runtime engine how to execute a query. So it's of course critical to performance. And so understanding what's in the access path will allow you to perhaps tune queries, get to the bottom of problematic query performance issues. So there's a couple main ways to view explain. You can use a GUI. So there's a visual explain that comes with the Db2 data management console, or there's a text-based version called Db2 EXFMT, and they both contain exactly the same information because they're sourced from the explain tables. But of course, the EXFMT is just a more basic text-based one. And there's also the Db2 EXPLN that seems like more folks are familiar with, and Martin likes to use it, but it's actually it gets its information from a slightly different place, and I'm going to talk more about that in a few slides. So why should you care about the explain facility? So of course, if you care about performance, and the performance kind of depends on the access plan in many cases, you'd want to take a look at the access plan to get a better understanding of why the query is running a particular way. You know, you can monitor changes in access plans to understand why performance might be degrading. You can look at the explain to understand the optimizer's decisions. And you can even use the explain tables to maintain a history of access plans over key transition periods. For example, you know, over a major version upgrade, sometimes well, the optimizer might have had some changes between releases, and maybe the plan changed because of those changes. If you've made a significant database or database manager configuration parameter change, for example, with the sort heap or CPU speed, those types of things affect the access plan. Maybe you've added some indexes, changed the amount of data, all those types of things could have resulted in an access plan change. So it's good to kind of monitor those over time. And also, if you have an older explain for when the query ran well, it's nice to have one to compare to if the query is maybe suddenly regressed, and then you can see exactly what's different in the new plan. So where does explain fit into the DB2 architecture? So diagram on the left is the different phases of query compilation within the DB2 engine. So sometimes the term query optimization, people think of that as referring to the entire process of compiling an SQL statement, but it's really just a couple of steps within the SQL compilation process. And after that query optimization phase, the in-memory data structures that represent the access plan will just be copied into a set of explain tables. And then from there, that's where the different tools will get the information. And of course, that access plan is then used to create something called an access section, which is actually the executable code that's run by the Db2 runtime engine. And that is also kind of really relevant to explain. I'm going to talk about that in a few more pages. So some examples of what explain looks like using the different tools. So this is what the explain graph would look like using data management DMC, data management console with the visual explain. So it's basically a graph. Each node of the graph represents a different runtime operator, like a join or a sort. The numbers represent the cost of the that particular access plan operator. And if you click on each of the nodes in the access plan graph, you can get a lot more information about how that operator executes. For example, we're looking at a hash join here. You can see what predicate is being applied, various other metrics associated with executing a hash join. Using Db2 EXFMT, of course, is a much more basic text-based graph. You can see it's good, but it's all the same information. It just maybe a little bit more has been chosen to be shown in the graph itself. So here we're looking at a nested loop join and a set of numbers for each node in the graph here. Here with the XFMT, we've chosen to show the output cardinality, which is the number of rows produced by each operator. So that's the number you're going to see above the operator name, which is in green, and then each operator is going to have a unique number, an identifier. And then below that, there's a couple more cost numbers. One is the estimated cost in a unit called timerons, and then below that, we also display the estimated IO. So lots of interesting information in the EXFMT. And then if you look at the base accesses, the tables and the indexes will also show the total number of rows in those objects as well. So first step to get started with doing an explain is you need to create these explain tables. And so if you're using the visual tools, they'll create them automatically. If you're doing it yourself, the best manual option is to use the sysinstall object store procedure. this store procedure is used to create a number of kind of system type of tables used by DB2. So in this case, you have to provide the explain option to create those tables. There's a C to create the tables. There's also a D to drop them if you needed to get rid of them for some reason. Alternatively, the actual DDL is shipped with DB2. You can find it under the SQLib MISC directory, and you could just execute it, yourself directly through CLP. There are 10 explain tables, and DB2 just inserts into those explain tables. Next page here shows a quick schematic of how they're related. So there's a kind of a hierarchy and referential integrity between all these tables, and each one stores different bit of information about the access plan. So the key one would be some information about the statement, and then each operator, and then for each operator you can either have predicates or arguments or stream information that's used to connect each operator in the access plan. And you don't really need to worry about how all these tables are structured and related to each other unless you want to run your own queries against them, which you can, which is kind of interesting if you want to do some of your own analysis. But the explain formatting tools will take care of all that for you. So how is explained information collected? So there's actually number of different ways to collect it, and that's what kind of the point of the presentation is, to cover most of them. And there are many different ways because SQL can be issued in different contexts. So with DB2 we support static SQL, so you can bind an application, and the SQL statement is prepared at bind time, and the access section is stored in the system catalogs. Or you can just issue dynamic SQL, so it only exists as long as the database is active and it's in the cache. But you can have SQL that's issued through stored procedures, triggers, and functions, and sometimes it's not even apparent that that there might even be an access section associated, with some of these objects. So, for the simplest case, if you just have an single SQL statement that you want to explain, the two most common methods are to use the explain statement itself. So you just prepend your SQL statement with the explain plan, and it'll populate the explain tables. Or you can use the current explain mode special register. So you set the special register, issue the SQL statement, and then turn off the special register, and again the explain tables are populated. So that kind of raises the question, which is the best one to use? And so they both have their their advantages and disadvantages. So the explain statement is useful if you want to uniquely identify each instance of the explain, because the explain plan statement accepts a query number and a query tag option, and so those will put that number and the tag into columns in the explain tables. So that way, if you're collecting a history of the explain information, you could more easily identify them in the tables. Or if you're using the explain mode special register, that's useful if you want to explain more than one statement and you don't have access to the SQL and you can't prepend the explain plan statement to it. And the explain mode special register also has, so it's got an explain value, so that means it just explains the statements, but you can also give it a yes option, which means it will explain and execute the SQL statements. If for some reason, one SQL statement depends on the other and you need to actually run them while you're explaining them. So we can have the bit of the debate about EXPLN and DynExplain. So here clearly we'll state that DynExplain, well, it's actually been discontinued and removed from DB2 in 10.1. So that's not even really an option now. As for DB2 EXPLN, and so it definitely has its uses, and as Martin says, it can be a very fast way to get a look at the access plan graph. However, if you really need to dive deeper into the optimizer's decisions, DB2 EXPLN doesn't contain nearly all the information that the explain facility provides if you use DB2 EXFMT, for example. So you can see, so with EXPLN, you can see, what the access plan operators are, what join it uses, what join order, what indexes were used, but you won't be able to understand why the optimizer had made those particular decisions. For example, there's not going to be any predicate selectivity estimates, and you're not going to be able to see what the query rewriter or query transformation phase did. But if all you really need to do is just see what index was chosen or what joined, then EXPLN will work fine for that. So now talk a little bit more about some more tricky context for doing an explain. So for example, if you have a dynamic SQL and it's already been prepared and you want to get the explain, so it might kind of beg the question, why would you even want to do that? So, often, you might have a problematic statements running poorly and you want to get the access plan. So, simple approach is, find that SQL statement, you use the two explain methods I just mentioned, you get the explain, look at the access plan. But what can happen in that case is that something in the environment might have changed since the query originally ran, and maybe it ran slow, and now now the access plan is actually different. Maybe stats changed, auto run stats kicked in, or if using self-tuning memory manager, maybe the buffer pool or sort heap changed. So if you really want to see what the access plan was when that query ran, then you have to actually explain. You have to take a look at the access section itself. And so prepared SQL statements, of course, they can exist in the dynamic statement cache. If they're static, they're going to be in the system catalogs. Or if you're using an activity event monitor, you can capture the sections, and they're stored in these monitor tables. And so that's where, if you really want to know what happened for a particular instance of an SQL statement running, you need to explain its section, not like re-prepare the statement and look at the new explain. You got to make sure you're looking at the right version of it when it ran. And so that leads us to this concept of explain from access section. So you might go, well, explain from section, I just said don't use DB2 explain because it's only based on the section. But the difference here is that with the explain from access section capability, there's a bunch of extra explain information that's sort of attached to this executable access section. And that's where the explain from information is going to come from. With DB2 EXPLN, it's just looking at the executable portion of the access section, which of course it's got to be, fairly lean and concise, for performance reasons. And so all this extra explain information is kind of attached to it. And and so this extra explain information can be retrieved from the attached part to the section through a series of stored procedures that are, there's 4 of them that are labeled explain from, and I'm going to go through those. So this notion of explaining from an access section conceptually really just takes three steps. First of all, you have to identify where the access section is located, and then you use that information and you pass that to one of these stored procedures, because there's different stored procedures depending on where the access section is located. And then the stored procedures are going to populate the explain tables just like the explain statement or the set current explain mode special register. And then after that, you just use your favorite formatting tool to see what's in the explain tables. And this explain from access section feature's been around since 9.7 Fixpack 1, so been around quite a number of years now. So quickly go through the different explain from stored procedures that you can use to do this. So probably the most common one is explain from section stored procedure, and use this if you want to explain a statement that's currently sitting in the package cache, or if you've used a package cache event monitor and the entries in an event monitor table. So there's a different flag that you pass to explain from section to indicate whether it's in the package cache or the monitor. But the key piece of identifying information for explain from section is something called an executable ID. And this is it's just a kind of a binary token, kind of internally really it's kind of based on the timestamp of when the access section was executed, as registered along with the access section. And I'm going to talk more about how to get this executable ID. There's various monitoring table functions that return the executable ID for a particular SQL statement. And then the second store procedure in this family is explained from activity, and use this if you've been using an activity event monitor. And so the section information has been written to this monitor table. And for that, with the monitoring, you'll have the application ID, activity ID, unit of work ID, and the activity event monitor name that you use to identify the table. You just pass that to this procedure. The third procedure, explain from catalog. This one is designed for explaining basically static SQL that's already in the system catalog. And so this, of course, is for your classic static SQL, but there's other types of things that might have static SQL that you're not aware of. I'm going to talk a bit more about that later, but you'll find it in the catalogs. And for there, you just need some, the package name and the section ID to locate it in the catalog. And then finally, the fourth procedure is just kind of a generic one that you can, since the access section is really just this binary object, you can create your own table, put it in a blob column, and just point this explain from data store procedure at it. So if you've collected the section using package cache monitor, activity event monitor, there's even some other monitoring functions that will just pull the section right out of the package cache. You can put it in anywhere you want and use the explain from data to explain it. And the common thing with all these procedures that the explain schema as input. So this is the set of explain tables that where you want to store the information, and it'll return the explain table key as output. Actually, one thing I forgot to mention earlier on, but the explain tables, there can be more than one set in different schemas for a given database. Kind of a common practice I see is that lately is that the explain tables will be created in the systools schema and shared for the system, but it's entirely possible to have your own set of explain tables in your own schema. So give an example of explain from access section, actual operations that we required to do that. So the first step, if you wanted to pull it directly out of the package cache, is you would use this mon get package cache statement table function, and that would give you the executable ID for a particular statement. And the and so you could search in the package cache on a variety of things, maybe based on a particular set of metrics. In this case, if it's the number of executions, it's actually been executed. Here it's looking for a DML statement, and then you could even search on the statement text if you're looking for a particular statement that you want to explain. The key thing here is you need to get the executable ID. And then once you have that, then you just call explain from section. You can pass in the executable ID. In this case, you can tell where it came from. In this case, I guess it was the package cache. It came from, actually, that should be a P rather than M. If it came from the monitor. And then the store procedure is going to return a set of output parameters that indicate how to find the explain information in the explain tables. And then you can just pass that to Db2 exfmt on the command line, and it'll format it for you. If you're using the data management console, you could you can point it at the explain table entry, and then it will give you the the graphical version of it as well. Of course, you can write store procedures and kind of code this up so that you don't have to manually pass the executable ID into the explain from sections. Since explain from sections SQL, you could write a wrapper store procedure to do this all in one procedure call. So an alternative method to using explain from section sometimes that can be, so with the explain from section, it's going to, when you call that, it's actually going to write the information directly into the explain tables. And maybe on a busy production system, if you wanted to collect the explains for a lot of different statements in the package cache, that might be too expensive to do. So another option would be you can just use another table function to just grab the access section and store that in a table. And then you can take that table maybe over to another database and then use the explain from data store procedure to get the explains, and then run the Db2 exfmt. So you can offload some of the explain processing from the production system over to this other system. So the only real activity you need to do in the production system is the collecting of the access section using the mon-get-section table function. And so this has been available for a while, since 10.5 Fixpack 4. So can move on to talking about what's the best method to explain static SQL statements. So so again, static SQL statements are when the access section is actually stored in the system catalogs. And there's really kind of two methods to explain static SQL. There's the traditional method, is where you can specify to do the explain when the package is bound. So there's an explain prep or bind option. It takes some options. Yes, just populates the the explain tables, as well as preparing the package. The all option is the same as yes, except when the package runs, and if there's dynamic SQL, it will actually explain the dynamic SQL when it's run. So that could be maybe a little bit dangerous. You want to be doing that on a test system. Or there's an only option where it won't create the package, but it will just populate the explain tables. So that was kind of the classical approach to doing it for static SQL. But sometimes, often, probably more often than not, you want to explain something that has a catalog entry, and the explain option wasn't specified when it was bound. And so then what do? It might not be practical to rebind the package just to get the explain. And then in some cases with triggers and functions, you might not even know that a package exists for them. So the alternative method, perhaps better, is that you can use the explain from catalog store procedure. And with this, you can get the explain after the package is bound, and you can even get it for triggers and functions. So certain types of triggers and functions will implicitly have a package that contains the body of the trigger and function, because they're by default will be static SQL. So the only gotcha with explaining the package for triggers and functions that you have to determine the package and name for them. And you can do that. It just requires a little bit of tricky SQL, but that's in the speaker notes in this presentation, which I'll be providing to Martin. And fortunately, with the store procedure, you can only explain one section at a time, but then you can kind of get around with that with writing a wrapper store procedure or a script or that type of thing. So so it's quite a handy way to get the stuff right out of the catalogs. All right, moving on to other topic. So with now we've talked about the notion of explaining an access section in a couple of different contexts, pulling it out of the package cache and or out of the system catalogs. Now there's some other ways that you can actually collect these access sections and then point the store procedures at them. So one the common way is to use the workload management feature. So you can create activity event monitors for different WLM entities like workload, service classes, these types of things, and then turn it on, and it'll collect the sections based on these types of things. Or you can even create activity event monitors for the default workloads and service classes that are shipped with DB2, but then this just means that all system activities is going to be monitored. So that's one way you can use activity event monitors with WLM. Right, sorry, before I get into the other method, just a few words on the differences between explain from access section and the regular explain that you do with the explain statement and the explain mode special register. So the key difference is that because this explain information, when it's with the section, is attached to the section, we don't include all the same information as with the full explain, because we don't want to use up too much package cache memory. And so only the most important information is included along with the section. So obviously the operators, the predicate text, the estimated cardinality, and most of the important operator arguments. So what exactly is not there is that the regular explain will show a number of other more detailed cost metrics, estimates for CPU and IO. So those won't be included. Things that take up a lot of space, like the names of columns that flow in the stream between operators, won't be shown. You know, if you're using the database partitioning feature, the partition columns won't be shown. Most statistics, of course, won't be shown because they take up a lot of space too. But still, it contains the explain from access section still contains a lot more information than what DB2 EXPLN will show, because in particular, it's got the predicate text, the estimated cardinality, and the filter factors. So, kind of good segue to another topic, which is how to. So, part of the process of optimizing an SQL statement is that the optimizer has to make some estimates about the number of rows that are processed by each operator, the estimated filtering of different search conditions, and that's probably the number one reason why an access plan might not be optimal, is that the optimizers made a misestimate in that calculation. And so with the explain facility, there is a mechanism that you can compare the optimizer's estimates to the number of rows that were actually returned as the query executed. And so this is something called explain with actual cardinality. And what it does is it'll as the query executes, it's going to capture the cardinality processed by each operator in the access plan. So not just sorry, for some reason that flipped out of. All right. Don't know what happened there. Something must have jumped on the screen. So it doesn't just show the final cardinality of the query execution. It will show the estimate. It will show the actual cardinality for each operator in the access plan, and then you can compare that to the optimizer's estimates, and that can give you some clue as to where the the optimizer might have made an error. And so to do that, so it's built into this explain from access section mechanism. Little fine print there, unfortunately, it doesn't yet work for column organized processing. So parts of the access plan that kind of run in the columnar engine doesn't yet have the ability to produce the runtime actuals. So how do you collect it? So to get the actual cardinality, you have to use an activity event monitor. Two different ways. So you can create the activity event monitor, enable it with WLM, or if you just want to do it for a particular session, there is a store procedure, WLM set con env. You can pass it these parameters to indicate to collect the section actuals. It's kind of in an XML string, and then when you run the statement as the activity event monitor is active, it'll write the information to the activity event monitor tables, and then you use the explain from activity store procedure to get that information from the section and write it to the explain table. So here, this next page will show you the kind of the nitty-gritty steps to do that. So in this case, if you're going to use WLM, you have to enable a DB configuration parameter, the section actuals, but you don't need to do that if you use the WLM set con env procedure. You do have to create an activity event monitor, so I didn't go through the details here, but there's a set of steps to create and set up that monitor, which creates a set of monitoring tables. So then you can either use WLM and create a workload, or again use this WLM set con env. Then you have to activate the activity event monitor, execute your SQL statement. So then the monitor is going to capture the access section for that. Then you find out where's your desired SQL statement in the activity event monitor table. You point the explain from activity store procedure add it, and that will populate the explain tables, and then you can use your favorite explain tool on it. So kind of an involved number of steps. You'd probably want to wrap that up in a script or a procedure. However, we do provide a command line tool that kind of does all that for you. For if you want to just pass a particular SQL statement. So this is the Db2 Capture Activity Event Monitor tool, and it just takes the SQL statement. Sometimes you might need to pass a schema or some other options like the degree that aren't maybe necessarily set in the environment. So those options were added in 11.5.6. So this is a handy way if you just want to look at the actuals compared to the estimates, and you have the ability just to issue the SQL statement, directly, from the command line or pass it to this tool. Some cases in some context, especially when executing SQL through a stored procedure, you might not be able to always do that. But this is a handy way if you can just issue the SQL statement. And then finally, when you do get the explain, the main difference that you'll see is there's an extra set of numbers in the output, and that will be the actual number of rows that were processed at runtime. And then you can compare them to the optimizer's estimates. And then, if you see big discrepancy between what the optimizer estimated in runtime, then you can start looking at things like are the statistics accurate? What was probably the first thing to look at would be any predicate search conditions, and compare the filter factors that the optimizer computed to reality, and then try to understand why the optimizer couldn't estimate a good filter factor. That's usually the first place to start. So it's a good segue on to explaining stored procedures, which is where explain from activity is particularly helpful. So you'd follow the same steps to collect the explain with the actual cardinality. So reason why this is really helpful for stored procedures is because often you can't just pull the SQL out of a stored procedure and execute it independently, because often the procedure might be using session tables, temporary tables, and so those don't exist until the procedure runs. Maybe you can't even see an SQL statement in the procedure because the procedure is dynamically generating it. So you'll find a bunch of string manipulation functions in the procedure that's putting an SQL statement together, but you're not going to see that SQL statement until you actually run the procedure. So in that case, it's best to, if you really want to understand how the access plans for these statements when the procedure ran, is to actually just run the procedure with the activity event monitor active, and it'll capture exactly what the procedure executed. And of course, unfortunately, you can't really do that with Db2 CAM because there yet you do actually have to have the SQL statement. But if you can run the procedure, this is the most precise way to get the access plan. Unfortunately, if you can't run the procedure, it's not ideal, but there still are some options. One is that procedures by default, the SQL will be static, so you can explain the static SQL in the procedures when the procedure is created, and you do that. There's a stored procedure called set routine ops, which basically just sets the bind options that will be in effect when the procedure is created. So as you do the create procedure, there's going to be an implicit bind for the static SQL in the procedure, and in this case it will do the explain, and then you can use Db2 XFMT as normal for that. Unfortunately, that's not going to handle dynamic SQL or even static SQL that references session tables. That SQL is also going to be implicitly dynamic because it really can't produce the access section until the session table exists at runtime. But at least this will get you the explains for the static SQL in the procedure. this topic is about adding some extra information to the explain that can be very helpful for understanding what was occurring when the SQL statement was executed. And so sometimes it would be nice to have like all the relevant statistics that the optimizer used in the explain. And so by default, the explain tables will contain some of the basic statistics, but it's not going to include everything because those can take up a lot of space. But if you want all of them, there is a way to do that, and that's with something called this explain snapshot. And it's just it's a binary object that it contains kind of a compressed form of all the statistics, and that just goes into a blob column in the explain statement table. And if the stats are in that column, Db2 EXFMT will automatically format them. And so you can get the snapshot by setting different special registers. So there's the we talked about the current explain mode special register. There's also the current explain snapshot special register. So if you specify that, it'll populate this blob column. Or if you're using the explain statement method, there's a with snapshot clause that will do the same thing. And if you want to see the stats yourself, and you're not using Db2 EXFMT, but they're already in the explain statement snapshot column, there's also a scalar function, explain format stats, that will do the same thing. And that's what Db2 EXFMT is actually using to format the stats as well. And so okay, why is this useful? Because you might say, well, the stats are in the system catalogs. I could just check the system catalogs. Well, what can happen if you have automatic stats collection running? Sometimes the stats aren't yet in the catalog. They're in something called the statistics cache. And so when the statement is explained, the optimizer is getting the stats from the stats cache and not from the system catalogs. So there might be some discrepancy. You do the explain and you go, wow, that plan doesn't really make sense compared to what I see in the catalogs. But then, maybe a few minutes later, you do the explain again, and then the plans change because the stats that were in the stats cache are now got stored in the system catalogs. So if you really want to see what stats were in effect when you did the explain, then you should collect this explain snapshot. And I kind of recommend doing that because it doesn't take up that much extra space, and you could always delete it if it has taken up too much space in the explain tables. Now, unfortunately, you can't really do that with the explain from access section capability because that would be way too much information to store in the package cache. So there are kind of some trade-offs depending on how you're getting your explain and how much information you can include. Next topic is about how to kind of track how the access plan has changed over time. So the most obvious way would be to just look at the explain information or the formatted explain, and you compare the explains, and then then you can see what did the join order flip or picked a different index. But doing this visually, or even if you have a tool, this can be expensive, and it's pretty complex for complex access plans. So there is an easier way to do that. The explain and the monitoring features produce something called a plan ID, which is basically it's a 64-bit hash of the access plan. So it's a hash of like the most important aspects of the access plan from a performance perspective, like obviously the operators, the order in which are executed, their arguments, and what tables or indexes have been used. And so whenever you do an explain, this plan ID is going to be included in the explain output. So you'll just see this plan ID, and it's it'll just be a hex string. But you don't even need to use the explain facility to get the plan ID. There's a number of these built-in monitoring functions that will return the plan ID. So if you're tracking SQL statements as they execute using the different monitoring functions, you can also pull out the plan ID. And then if you want to save the plan ID and some of the monitoring metrics, you can you can check and see if that plan ID has changed over time for a given SQL statement. And so you have to consider that a plan ID is unique to a particular SQL statement and a particular, what I'm going to call, semantic environment. So a particular SQL statement is kind of straightforward. Different. Each SQL statement could have a different access plan. Sometimes the same SQL statement can have, or sometimes different SQL statements could actually have the same access plan or plan ID. But the point is that it really kind of depends on the SQL statement. The semantic environment item, what this basically says is that sometimes you might have exactly the same SQL statement text, but the SQL didn't use qualified table references. So it could actually be referencing completely different tables or functions depending on the schema and the function path that was set when the statement executed. So you do need to have the semantic environment ID to distinguish, whether a particular SQL statement's really the same. Even though the text is the same, it could actually be, semantically referencing completely different. So you take those two into account, and then that'll provide you the proper context for understanding the plan ID. And the statement ID itself is a hash of the SQL statement text, but we do this normalization of the statement text so that literals in search conditions are removed, so that the statement ID will have the same hash. For example, for this this very simple statement, looking for a particular customer ID, the hash for the statement ID would be the same here. So because if you've got an application that's not using parameter markers, you really don't want to see a different statement ID for what's effectively the same statement. But given that the search condition could affect the selectivity estimate, which in turn could affect the access plan, this is an example of where you might see different plan IDs for a given statement ID, because there could be different access paths depending on what that literal was. So the semantic environment ID and statement ID are all in the explain table information as well. These are represented as arguments on the return operator, and they're designed to be stable across fixed packs and releases. So if you've recorded them, an older release, and you've migrated and you want to compare them, they should still be comparable. And the plan ID doesn't change if the tables or indexes are dropped and recreated, as long as they have the same definition, because the plan ID excludes the object schemas. And that's handy, because what you could do is you could take the schema from a production system and put it on a test system and do the explains on the test system, and then you could compare them with the production system to see where they might change if you want to try different experiments like new indexes or that types of things on the test system. So some of these tips are kind of about how to avoid using explain to test access paths, because we have that information kind of all wrapped up in this plan hash, this plan ID. So you don't even need to do the explain if you can get the plan ID from the monitoring functions. And even if you have the explains and you want to get the plan IDs from the explains, you can get them from the explain tables, although it requires a little bit of SQL pivoting to return that, and then that SQL statement's in the speaker notes. And kind of moving to the last few topics in the presentation, another feature provided with the explain facility is these explain diagnostic messages. So they go into a separate set of tables in the explain schema, and they provide some interesting information, such as whether tables or indexes are missing stats. If you're using materialized query tables or statistical views, it'll indicate whether or not they were used or they could be matched. If you're using this feature called an optimization profile, which Martin says I shouldn't talk about, they're basically a form of access path hint. And if you've got syntax errors in the hint, you'll find them in the explain diagnostic messages. And it'll provide some index recommendations in limited context as well. and every release we might tend to add a few more interesting diagnostic messages to kind of help you with performance tuning.
I should explain myself. I actually was in sessions going back, golly, I want to say 1987. Yes, I am that old. Where people were saying the optimizer isn't doing what I want it to do, so I just kind of like want to make it do what I think it should, and that's what optimization profiles are in support of. And my firm belief is the optimizers generally considered many more things than humans have time to, and as such, an optimization profile is an attempt to make the human smarter than the code that's in the optimizer. And I firmly believe the optimizer is doing the right thing. So there.
I totally agree, Martin. Yeah, I totally agree. Yeah, I just we have them there kind of for emergency purposes.
Oh, absolutely.
And
yeah. I'm sure there's every tuner that's around the country going places is going to have something where they just don't have time to fully understand it, but they needed to do something else. They make the change and performance will get better. That can happen.
Yep, and I always recommend, once you've, solved the emergency, kind of go back and try to understand why you needed to do that, and see if you can find a better tuning approach to avoid the hint altogether.
And the other part of that too is if you're a tuner doing that and you leave the hint behind, how do you know that things haven't changed such that the hint needs updating or other changing and maintaining that in the future is another problem.
Yep, good, very good point. Yep. All right, so there's an example of some explained diagnostic messages. I kind of talked about them on the last page. Some words on the upgrading explain tables. Sometimes in new releases, we might add new explain tables. Actually, I haven't done that in quite a while, but we might often add some new columns. And the previous explain tables are upwardly compatible, but you might lose some functionality if if you don't have those additional columns. So it's good if you can to upgrade your explain tables. Now, if they're empty, well, it's not a real big deal. You could just drop and recreate them. But we do support a migration tool. So there's a command line version of it, Db2 exmig, or the sysinstall object store procedure I mentioned earlier that's used for creating the tables. It does support an M option for migrating them, and there it will create the new version, copy over or I think it just adds the columns to the existing tables. Last tip. So the explain only inserts into the explain tables. It doesn't. The Db2 engine doesn't do any kind of administration to prune stuff. So kind of leave that to the user, but it's easy to do because there's referential integrity defined on all the tables. So if you want to just get rid of everything, if you do a delete from explain instance, it will just clean out all of the explain tables. And that takes us to the top of the hour, and that was the last item I had to cover. So I don't know if we're taking any questions now, Martin, or we're wrapping up.
There's no questions today. I think you've done a great job. I've learned a few things there in terms of explaining stored procedures and stuff. That was really good stuff. Appreciate you taking the time to go through this with us. But before we let people go, let me take back control here, and so I can do the final polling question. And I'll show my screen. There you are. I'm going to go ahead one slide, but the last polling question is our famous one is, did you learn anything today? And let me launch that. And I figure every time I can go to a presentation like this and learn something, that virtually everybody else should be learning something too. But of course, that's why it's a free society, and that's why we give people a chance to vote. And what we're seeing today is that, once again, it seems I'm quite an agreeable fellow because everybody's agreed that they learned something today, which is absolutely fantastic, John. Thanks again so much for the great information.
You're welcome. Thanks for having me on, Martin.
And I look forward to getting your slide deck and posting that shortly along with the replays. So let me wish everyone a good weekend. If you're traveling, certainly up here in Ontario, we're in the March break and the airline would be busy today, and it's snowing. Well, can happen anytime in Ontario, where we live at this time of year on any given day. So I hope everybody stays safe, has a great, pleasant weekend, and we'll see you in 2 weeks for our next DB2 on Zed show with Mariella Wyrack. And other than that, we'll sign off for today. Cue the music. We'll thank John again profusely for doing such a great job. And with that, we'll see you next time on the DB2 Night Show. Bye-bye, and thank you all. Thanks, John.
You're welcome, Mark. Bye-bye.
Bye-bye.